Vancouver, a city renowned for its natural beauty and vibrant culture, sits atop a geological time bomb, the Cascadia Subduction Zone. This fault line, stretching from northern California to Vancouver Island, has the potential to unleash earthquakes of catastrophic magnitude. Recent seismic activity, including a significant 6.4 magnitude quake off Vancouver Island, has put geologists on high alert. The ground beneath our feet is constantly shifting, a reminder that we live on a dynamic planet. Vancouver, nestled along the Pacific Ring of Fire, is no stranger to these tremors. The Cascadia Subduction Zone is not a single fault, but a complex system where the Juan de Fuca tectonic plate grinds against and dives beneath the North American plate. Understanding the science behind this geological phenomenon is crucial for comprehending the risks and preparing for the potential consequences. The Cascadia Subduction Zone is a massive fault line stretching over 600 miles along the Pacific Northwest coast. It's a place where two tectonic plates, the Juan de Fuca and the North American, collide. The Juan de Fuca plate, denser and heavier, is forced under the North American plate in a process called subduction. This slow-motion collision, occurring over millions of years, is responsible for the majestic volcanoes and picturesque mountains that define the region's landscape. However, this beauty comes at a price. The plates lock together, building up immense pressure over time. This pressure, like a tightly wound spring, can only be released in a sudden and violent rupture, an earthquake. The last time the Cascadia Subduction Zone unleashed its full fury was in 1700. The resulting earthquake, estimated to be around magnitude 9.0, sent tsunamis racing across the Pacific Ocean, reaching as far as Japan. Today, the Cascadia Subduction Zone is locked and loading, accumulating stress with each passing year. Given the last major event was over 300 years ago, the question isn't if, but when, the next big one will strike. In recent years, a series of smaller earthquakes has rattled the region, serving as a stark reminder of the Cascadia Subduction Zone's potential for seismic activity. On July 11, 2024, a 6.4 magnitude earthquake struck off the coast of Vancouver Island, shaking buildings and rattling nerves. This event, while not directly on the main subduction zone fault, occurred near the intersection of several smaller fault lines, highlighting the complex interplay of geological forces in the region. Adding to the concern is a cluster of smaller earthquakes detected in the same area near the Juan de Fuca spreading ridge, the Savanco fracture zone, and the Nootka fault zone. These swarms of tremors, while not individually destructive, indicate increased stress and strain along these fault lines. The recent seismic activity, while unsettling, serves as a crucial reminder of the importance of preparedness. Understanding the risks and taking proactive steps to mitigate potential damage is essential for individuals, communities, and governments alike. The potential consequences of a major earthquake along the Cascadia Subduction Zone are staggering. Scientists predict that a magnitude 9.0 earthquake would unleash unprecedented devastation across the Pacific Northwest, impacting millions of people and causing billions of dollars in damage. Coastal communities would face the brunt of the impact, inundated by massive tsunamis generated by the sudden displacement of the ocean floor. These towering walls of water, some potentially reaching heights of over 50 feet, would surge inland, swallowing entire towns and cities. Estimates suggest that a magnitude 9.0 earthquake could result in thousands of fatalities and tens of thousands of injuries. Beyond the immediate impact, the aftermath of a major earthquake would be equally challenging. Power outages, potentially lasting for weeks or even months, would cripple communication networks, disrupt transportation systems, and hinder relief efforts. Section 5. Science to the rescue, monitoring the unseen depths. Despite the inherent unpredictability of earthquakes, scientists are making significant strides in understanding and monitoring the Cascadia Subduction Zone. Advanced technologies and innovative research methods are providing valuable insights into the fault's behavior, allowing for better risk assessment and potentially even early warning systems. One promising area of research focuses on slow-slip events, subtle movements along the fault that occur over days or weeks. Scientists believe that monitoring these slow-slip events can provide valuable clues about the build-up of stress along the fault. Another crucial aspect of earthquake research involves mapping the Cascadia Subduction Zone in unprecedented detail. Furthermore, the deployment of advanced sensors and monitoring equipment along the ocean floor is providing real-time data on the fault's movements. Section 6. Preparing for the inevitable. What you can do. While the prospect of a major earthquake can feel overwhelming, there are concrete steps individuals and communities can take to prepare for such an event and mitigate its potential impact. One of the most crucial aspects of earthquake preparedness is creating a family emergency plan. This plan should include evacuation routes, designated meeting points, and a communication strategy in case family members are separated during an earthquake. It's also essential to have an emergency kit readily available containing water, non-perishable food, first aid supplies, a flashlight, a radio, and other essential items. Securing your home is another essential step in earthquake preparedness. Community-level preparedness is equally crucial, including participating in local earthquake drills and advocating for stricter building codes. Section 7. A coast on edge, comparing seismic threats. The Cascadia Subduction Zone is not the only seismic threat facing North America's west coast. The San Andreas Fault, running along the length of California, is another major fault line capable of generating devastating earthquakes. While the two faults differ in their geological characteristics and earthquake potential, both pose significant risks to densely populated areas. The San Andreas Fault is a transform fault where two tectonic plates slide past each other horizontally. The 1906 San Francisco earthquake, a magnitude 7.9 event, is a stark reminder of the San Andreas Fault's destructive power. The Cascadia Subduction Zone, on the other hand, is capable of generating much larger earthquakes, exceeding magnitude 9.0. Understanding the unique characteristics of each fault and implementing appropriate preparedness measures is crucial for mitigating the potential impacts of these inevitable events. Section 8. Conclusion. Living with uncertainty. Living in the shadow of a sleeping giant like the Cascadia Subduction Zone requires a unique blend of awareness, preparedness, and acceptance. While we cannot prevent earthquakes, we can strive to understand them better, mitigate their potential impacts, and build more resilient communities. The recent uptick in seismic activity serves as a timely reminder of the forces at play beneath our feet. By embracing a culture of preparedness, we can face the future with greater confidence, knowing that we are taking proactive steps to protect ourselves, our loved ones, and our communities. The Cascadia Subduction Zone is a constant reminder of our place in the grand scheme of geological time. While we may never be able to predict earthquakes with absolute certainty, we can choose to live prepared, informed, and resilient in the face of uncertainty.